Welcome back. This is Mrs. Rubright with Algebra 1 Honors. Today's lesson is 8.5, Solving Quadratic Equations by Graphing. Alright, so, finding intersections of lines and parabolas. The graphs of three quadratic functions are shown. So parabola A is the graph of f of x equals x squared. That's the parent function, right? That's what we're used to looking at. So y equals x squared would be 0, 0. 1 squared is 1. Negative 1 squared is 1. 2 squared is 4. Negative 2 squared is 4. This is our parent function. This is what we model everything after. Okay, so that's this. Parabola B is just shifted up 4, right? So this next one, this just means that it's shifted up 4. So instead of at 0, 0, it's at 0, 4. Instead of at 1, 1, it's at 1, 5. Right? It's still going over 1, up 1, over 2, up 4. It's following the same shape. It's not vertically stretched or shrunk. It's just shifted up 4. And then our final graph, this one is shifted what? Up. What does this plus 8 do? Up 8. Compared to our parent function, right? You guys remember? If the plus or minus on the outside, it's up or down. If it's inside the parentheses, it's left or right, opposite of what you think. Is it starting to come back after the weekend? On the same coordinate grid, graph the graph, y equals 4. What type of function is this? Describe its graph. What would y equals 4 look like? Where's y 4? Y is 4 here. Y is 4 here. Y is 4 everywhere on this horizontal line. This horizontal line is the line y equals 4, or g of x equals 4. Because g of x is the same thing as y, right? It is a linear function. It's linear, right? It's a constant function. It's a horizontal line. Horizontal lines have what kind of slope? Horizontal, 0 slope. At how many points does the graph g of x intersect each parabola? So with A, where does g of x intersect A? How many points? This blue line and the orange line. How many times does it intersect it? Twice. How many times does it intersect B, the green one? Once, at the vertex, right? And how about C? 0. Use the graph to find the x-coordinate of each point of intersection of the graph of g of x and parabola A. Show that the x-coordinate satisfies the equation x squared equals 4. Okay, so where does it intersect this one? It's at 1, 2, and negative 2. 2 and negative 2. And then if I plug that into this equation, 2 squared equals 4, yes. And negative 2 squared equals 4, yes. That satisfies that equation. Use the graph to find the x-coordinate of each point of intersection of g of x and parabola B. All right, so where does it intersect parabola B? It intersects it at 0, 0, right? At x equals 0. And if I plug that in here, I'd get 0 squared plus 4 equals 4. 0 plus 4 equals 4. 4 equals 4? Sure does. So it satisfies this equation. Describe how you could solve an equation like this graphically. What could you do? You could treat each side of the equation as a function and graph it. Find the x-coordinates of any points of intersection. Right? You could graph y equals 7, you can graph y equals x squared plus 5 and see where they intersect. Another thing you could do is just solve it, right? You could just go x squared equals, subtract 5 from both sides. X squared equals 2. Square root, positive negative square root of 2 is your x, right? You could actually just solve it, and that's where they're going to intersect. You can solve an equation in the form of a, comma, x minus h squared plus k equals c, which is called a quadratic equation, by graphing the functions, this and this, and finding the x-coordinate for each point of intersection, right? So you're graphing this, graphing each side. All right, so solving this. We can solve this separately. Well, if y equals 7, that would be that. That's the easier one to draw, right? Y equals 7 is there. So they're saying that y equals that versus y equals all that. Well, on here, my vertex is 4. It's opposite of this, 4, comma, 1. We know it's going upward. We can graph points to each side. We can do the y-intercept because that's always an easy one to do, right? So if I plug in a 0 for y, if I set this equal to 0, what would I have? Oh, sorry, 0 for x. If I plug in a 0, I'd have negative 4. Negative 4 squared is 16 times 2, 32, 33. Okay, that's not making sense. What am I doing? What are they saying to do? If you move 1 unit to the right or left of the vertex, how must you move vertically to be on the graph of... Okay, so what is this 2 doing? If we're thinking about parent functions, what is the 2 doing? It's a vertical stretch of what? Vertical stretch by 2. So instead of over 1, up 1, it's over 1, up how many? Instead of over 2, up 4, it's up how many? 4 times 2 is 8. And where do these guys intersect? There and there. You'd be at 5, comma, 3, and 3, 3. Okay, so you have your 2 points. X is approximately 2.3, and x is approximately 5.7, is these 2 points that I just showed you. For each x value from part C, the value of f of x, how does it show that you have found actual or approximate solutions? So for here, we're going to say f of 2.3 is approximately 2 times 2.3 minus 4 squared plus 1, which is 2 times negative 1.7 squared plus 1. 6.78. F of 5.7 Alright, so once you plug those in, because the function values are not exactly equal to 7, the solutions are approximations. They're not exactly perfect solutions. Like, they don't exactly intersect properly. If you solve the equation 4 times x minus 3 squared plus 1 equals 5 graphically, would you be able to obtain exact or approximate solutions? Explain. So, exact, because the parabola and line intersect at points where the horizontal and vertical grid line crosses. For what value of c would the equation have exactly one solution? What is the solution related to the graph f of x? C equals 1. It is the y coordinate of the parabola's vertex. All right, solving a real-world problem. While practicing a tightrope walk at a height of 20 feet, a circus performer slips and falls into a safety net 15 feet below. The function h of t equals negative 16t squared plus 20, where t represents time measured in seconds, give the performer's height above the ground as he falls. Write and solve a solution to find the elapsed time until the performer lands in the net. Write the equation that you need to solve. Okay? So, what do I need to solve? I need to solve negative 16t cubed plus 20 equals, what do you think? What do you just think I'm doing? Equals 5. Why? Can someone explain? Yeah. Yep. Yep. Okay. So it says, while practicing a tightrope, you're at a height of 20, the net's at a height of 15, it's 15 feet below, right? So it's at a height of 5 feet off the ground. If it's 15 feet below, it's 5 feet off the ground. You will solve the equation using a graphing calculator. Because the calculator requires you to enter functions in terms of x and y to write the equations of two functions that you will graph. See, you guys are not going to get a graphing calculator, so just don't even worry about this. They don't give you a graphing calculator on your EOC, so just ignore that. All right, well, let's do some practice. Solve each quadratic equation by graphing. Indicate whether the solutions are exact or approximate. All right, so if we're going to solve this by graphing, we're going to have a y equals 3. Do you guys understand what we're doing? So, like, remember how when we solved equations by substitution, we set them equal to each other? This is like having two separate equations of, like, y equals x plus 2 squared minus 1, and y equals 3. But with substitution, you set this equal to this. And that's what's going on here, is they're just, instead of, like, having to FOIL everything out and move things around and turn it into a quadratic equation, they're like, well, it's easier to just use it the way that it's written than to have to do extra work. And I can show you both ways. So first, let's do y equals 3. One, two, three. So this is our first line, right? This is y equals 3. This is the y-axis. This is the x-axis. Okay? So now, it's graphing this one. Your vertex would be negative 2, comma, negative 1. Opposite of this, same as this. And we know it's going upward because it's a positive x, right? Let's plug in x equals 0 for the y-axis. If I was doing this one right here. If x equals 0, I'd have 2 squared is 4. 4 minus 1, 3. Put in my axis of symmetry. 2 to the axis of symmetry, 2 away. This is what it should look like. Let's see if this makes sense. There's no leading coefficient that's saying a vertical stretch or shrink. So if we went over 1, up 1, over 1, up 1, over 2, up 1, 2, 3, 4, that verifies that, right? It's following that normal pattern. So my solutions, where these two intersect, are here and here. Solve it by graphing. X equals what? 0. And x equals -1, -2, -3, -4. And those are exact solutions, right? They intersect those exactly. What if I turned this into like a legit quadratic equation? So I'd have x plus 2 times x plus 2. That's x squared plus 2x plus 2x plus 4. Minus 1 equals 3. X squared plus 4x. 4x. All right, 4 minus 1 is 3. And then I'm going to subtract 3 from both sides. So I'd have this, right? I have y equals x squared plus 4x, right? Because I'd have 4 minus 1 is 3, and then 3 minus 3 is 0. That would be my equation. So if I was going to do this one by factoring, I'd have x times x plus 4. So I'd have zero product property, x equals 0, x plus 4 equals 0. So my solutions would be 0 and -4 by factoring. What if I did it by graphing? Well, I could take this, negative b over 2a. -4 over 2 times 1 is -4 over 2, or -2. Plug back in to get my vertex. So -2 squared is 4. 4 plus -8 is -4. Once I have my vertex of 2, -1, 2, 3, 4, -2, -4, I can go over 1, up 1, over 1, up 1, over 2, up 4, over 2, up 4. And here's my graph. Where's my solutions? Where they cross the x-axis. Oh, sorry, I didn't pull this up. There we go. So I would still get those same two solutions from graphing using negative b over 2a and then following the pattern, or doing 2 points to the left, 2 points to the right, plug and chug. I could do it using my equation and factoring and setting my factors equal to 0 and solving. Or I could do it this way, where I have a line at y equals 3, and then I graph this, and I see where those intersect. Yes? Yes. So let's do another one, and we're going to do it the way that this intends us to do it, which is to do the two separate equations. So if I had the equation y equals 2 times x minus 3 squared plus 1, and y equals 5, I'm going to graph both those lines and see where those two lines intersect. Does that make sense? You guys see how there's multiple ways of doing this? There's so you have tons of ways to double check your work. All right, so y equals 5. 1, 2, 3, 4, 5. We have this line, y equals 5. This is the y-axis, this is the x-axis. Second line, our vertex is at what? What's my vertex? 3, 1. Opposite of this, same as this. 1, 2, 3, 1. Up or down? It's going up, right? Vertical stretch by a factor of 2. So instead of over 1, up 1, over 1, up 2. Over 1, up 2. Over 2, up. Instead of up 4 is up 8. 1, 2, 3, 4, 5, 6, 7, 8. Where do they intersect? Here and here. Is that an exact point? Not really, right? So x is approximately 1.6, and x is approximately 4.4, and it's approximate. I can't tell exactly where it is. I'm guessing. Right? These 2 points of intersection. Try number 3. We're going to create those 2 separate equations and see where they intersect. Three squared is 9, half of that is 4.5. 1, 2, 3, 4.5. 16, half of 16 is 8. 1, 2, 3, 4, 5, 6, 7, 8. Are you guys able to start graphing some points? I did it based on the parent function. Based on the parent function, I shifted up 2. So instead of 0, 0, I'm at 0, 2. Instead of over 1, up 1, it's over 1. It's reflected down, down a half. Over 1, down a half. Instead of over 2, down 4, half of 4 is 2. Over 2, down 2. Over 2, down 2. Instead of over 3, 3 squared is 9. Instead of over 3, up 9, it's over 3, down 4.5. Right? Negative a half of that. 4 squared is 16, so instead of over 4, up 16, it's over 4, half of 16 is 8, down 8. Make sense? Vertical shrink by a factor of 1/2. Are you guys understanding this? Hopefully. Let's try another one. This is going to make it go down, right? If I was graphing y equals -6, y-axis, x-axis, 1, 2, 3, 4, 5, 6. Graphing this, I have the vertex of 3, negative 2. And we know it's going down, right? Does it have a vertical stretch or shrink? No. So over 1, down 1. Over 1, 1. Over 2, 1, 2, 3, 4. Over 2, 1, 2, 3, 4. It has a perfect intersection here and here. This is going to be an exact answer. And what's my exact answer? That's going to be x equals 1 and x equals 2, 3, 4, 5. X equals 1 and x equals 5. Exact. Yeah. Yeah. We're over here. I don't know exactly where this is. It's like around 3.5, right? 1, 2, 3.5-ish. 1, 2, 3.5-ish. But here, I know that it's exactly intersecting at those points. Because when I went over 2, down 4, it perfectly intersected at y equals negative 6, right? And I'm just giving the answers to the x values when it intersects y equals negative 6. As part of an engineering contest, a student who has designed a protective crate for an egg drops the crate from a window 18 feet above the ground. The height of the crate as fallen is shown as this, where t is the time in seconds since the crate was dropped. Write and solve an equation of the elapsed time until the crate passes a window 10 feet directly below the window from which it was dropped. If it's 10 feet below the window that's at 18 feet, it's at a height of 8 feet. So we're looking when it's at a height of 8 feet, right? Because it's 10 feet lower, and it's at a height of 8. Do we agree? All right, so we're looking for 8 feet for our height. Our height is our y, so it's going to be 8 equals negative 16t squared plus 18. That's our equation. So what's our t going to be? We could just solve it normal, right? Minus 18, minus 18. What is 8 minus 18? Negative 10, right? Equals negative 16t squared divided by negative 16. 10 over 16. 0.625 equals t squared, square root, square root. T is approximately positive negative 0.79. Can you have a negative 0.79? No, so it's just going to be 0.8. So 0.8 seconds. It's going to be approximately 0.8 seconds. Write and solve an equation to find the elapsed time until the crate hits the ground. Okay, so we have our negative 16t squared plus 18 equals a height of 0. When will it be at a height of 0? Well, we'd have negative 16t squared equals negative 18. Divide by negative 16 on both sides. 18 divided by 16 would give us t squared equals 1.125. Square root, square root. Our t is approximately 1.1, 1.06 or 1.1 seconds. Is the crate's rate of fall constant? Explain. All right, so for the first 10 feet, the average rate of fall was 10 feet per 0.8 seconds, which is 12.5 feet per second, right? For the remainder of the fall, it was 18 minus 10 over 1.1 minus 0.8, and that gave us 8 over 0.3, which is 26.7 feet per second. Is that the same? So it's not constant. Duh, it's not constant, it's not linear, right? It was increasing. The rate was increasing. Well, think about a parabola. A lot of, like, it's going more and more steep, right? It's kind of similar to things when they're like exponential. It's like growing quicker. It's falling faster. It's parabolic. All right, so your additional practice, your homework tonight is workbook pages 441 and 442 on 8.5. I hope you guys enjoyed today's lesson. Please like and subscribe and have a fantastic